Our sun, the anchor of our solar system, appears calm from Earth. But beneath that golden glow lies a churning, dynamic nuclear furnace. Its surface boils with magnetic energy, following a grand rhythm, the solar cycle, lasting about 11 years. Right now, we're approaching the solar maximum, when sunspots and solar eruptions peak. These sunspots, far from being mere blemishes, are the source of the sun's most powerful outbursts. The solar cycle isn't just an astronomical curiosity. It shapes life on Earth, especially our technology. As we near the 2025 peak, the sun's activity can both dazzle us with auroras and threaten our electronic infrastructure. We're no longer passive observers. Our technology and our ability to monitor the sun have never been more advanced. This story is about our evolving relationship with our star, the risks, the beauty, and the science that gives us foresight. We'll explore the heart of a solar storm, revisit history's most dramatic solar events, and see how science helps us prepare. The sun's power is not a cause for fear, but a call for understanding and readiness. Let's begin our journey into the sun's rhythmic pulse. The solar cycle is the sun's slow, powerful breath, an 11-year rise and fall in activity. During the solar minimum, sunspots are rare and the sun is quiet. As the cycle ramps up, tangled magnetic fields break through the surface, creating more sunspots and setting the stage for solar storms. We're now in solar cycle 25, expected to peak in 2025, and it's proving more active than scientists first predicted. Sunspot numbers are higher than forecast, increasing the odds of significant space weather events. More sunspots mean more chances for magnetic fields to snap and unleash energy, fuel for powerful solar eruptions. This is a natural, recurring phenomenon. Life on Earth has always adapted to these cycles. What's changed is our vulnerability. Our technology is now deeply intertwined with the sun's moods. Power grids, satellites, and communications are all at risk during solar maximum. The sun isn't more dangerous. It's our reliance on sensitive electronics that raises the stakes. As we approach the 2025 peak, awareness and preparation are more important than ever. Understanding the solar cycle is key to protecting our modern world. The sun's rhythm continues, and so must our vigilance. Solar storms are driven by two main phenomena: solar flares and coronal mass ejections, or CMEs. A solar flare is a sudden burst of radiation from sunspots, sending X-rays and ultraviolet light racing to Earth in just over 8 minutes. While this radiation can't harm us directly, it can disrupt the ionosphere, causing radio blackouts for aviation and maritime operations. The real threat often comes next: a CME, a massive cloud of magnetized plasma hurled into space. If a CME is aimed at Earth, it can arrive in 1 to 4 days, triggering geomagnetic storms that threaten power grids and satellites. These storms also create breathtaking auroras, as charged particles collide with our atmosphere near the poles. Solar flares and CMEs are the sun's way of reminding us of its power and our need to be prepared. Understanding these events is crucial for safeguarding our technology. Earth's magnetosphere is our invisible shield, generated by molten iron in the core deflecting most of the solar wind. When a CME strikes, it compresses and distorts this shield, sometimes allowing energy and charged particles to pour into our upper atmosphere. If the CME's magnetic field is oriented just right, opposite to Earth's, it can trigger major geomagnetic storms and spectacular auroras. These storms drive powerful currents in the ionosphere, which can induce unwanted currents in power grids, a direct threat to our technology. The magnetosphere protects us, but during severe storms, it can also channel the sun's energy into our infrastructure. Our planet's natural defenses are strong, but not infallible. Understanding this shield is key to managing space weather risks. On March 13, 1989, a powerful solar storm plunged 6 million people in Quebec into darkness. A CME struck Earth, and the region's geology made its power grid especially vulnerable to geomagnetically induced currents. Within 90 seconds, the entire grid collapsed. Trains stopped, airports closed, and millions woke to a cold, dark morning. The blackout lasted 9 hours, revealing just how dependent we are on electricity. The 1989 event was a wake-up call. Solar storms can cause real, costly disruptions. Satellites malfunctioned, and auroras were seen as far south as Florida. This event moved space weather from science fiction to a real-world risk for engineers and governments. It showed that a storm from the sun can have immediate, dramatic effects on Earth. The Quebec blackout remains a crucial lesson in the vulnerability of our infrastructure. It's a reminder that space weather is a practical risk, not just a scientific curiosity. The Carrington event of 1859 remains the most powerful solar storm on record. Richard Carrington witnessed the first solar flare, and hours later, a massive CME triggered global geomagnetic chaos. Telegraph systems sparked and failed, operators were shocked, and auroras lit up skies worldwide. If a similar event struck today, the impact on our power grids and technology would be far greater than in 1989. High-voltage transformers could be destroyed, leading to prolonged blackouts for millions. The Carrington event is the benchmark for worst-case solar storms, a reminder of the sun's potential to disrupt modern life. It's not about apocalypse, but about the scale of disruption possible in our connected world. History urges us to prepare for the sun's rare but extreme outbursts. As we approach the 2025 solar maximum, our greatest risk is to the technology that powers our society. Power grids are vulnerable to geomagnetic storms, as history has shown. Satellites face radiation damage and orbital decay, threatening communications, navigation, and even financial systems. GPS disruptions would ripple through industries, from aviation to banking. High-frequency radio blackouts could ground flights and disrupt shipping. Even undersea internet cables could be affected by induced currents. The threat isn't existential, but it is societal. Large-scale technological disruption is the real risk. Our challenge is resilience building systems that can withstand the sun's natural fury. We're not powerless against the sun. Science is our shield. Spacecraft like NASA's Solar Dynamics Observatory and ESA's satellites monitor the sun around the clock, giving us early warnings of flares and CMEs. Satellites at Lagrange Point 1 provide crucial minutes to hours of advance notice before a solar storm hits Earth. This warning time allows power grid operators to protect infrastructure and satellite controllers to safeguard their assets. Airlines can reroute flights, and engineers are hardening systems against space weather. Science gives us foresight and resilience, turning a natural hazard into a manageable risk. By watching the sun and acting on what we learn, we transform fear into preparation. Our sentinels in space stand guard, keeping our world safe from cosmic weather. Knowledge is our best defense. The sun is both our life-giver and a source of potential disruption. Its cycles and storms are natural, not flaws, and have shaped Earth for billions of years. The 2025 solar maximum is a story of understanding, not doom. We've learned to anticipate the sun's moods and take precautions. Our connection to the cosmos is deep. Auroras remind us we live within the sun's reach. The challenges of space weather are the price of living near a dynamic star.